Think about the word average. I'm sure you've used the word, I'm sure you've heard it, and I'm sure you've seen it in a lot of real-world applications. Write down anything you know about average. What is it? When would you use it? Where have you heard it or seen it? The most common version or definition of the average is the mean or the arithmetic mean. This is the arithmetic average, the central value of a set of numerical values. To find this, you add up all of the values in the set. So I have a set of values, 10, 13, 23, 8, 17, and 1. I'm going to add them all up. I get a total of 72. Take this sum. I'm going to divide this sum by the total number of values in the set. Well, the sum of all those values is 72. But there are 1, 2, 3, 4, 5, 6 values in that set. So I'm going to take 72, divide by 6 to get 12. My arithmetic mean is 12. My average is 12. The mean is very important. Most times when someone asks for an average, they're referring to the mean. Let's try a couple examples together. So we're going to take this next set of values, add them all up. That negative 29 should not change how you do the problem. Remember, we're taking individual values and adding them together. 6 plus 10 plus 12 plus negative 29 plus 28 equals 27. Whether you do this using the order of operations or you try plugging that all into your calculator. Remember, the more you type into your calculator at once, the higher probability you have of making an error. So be careful. The more steps you can do on the paper, usually the safer you are. Plus, you can go back and check where you made your error, where you made your mistakes. So now that I have my sum of 27, I'm going to divide it by how many values there are. There's 5 values, 6, 10, 12, negative 29, 28. That's 5. So 27 divided by 5 gives me 5.4. Notice that the mean does not necessarily have to be one of the values in the list. Sometimes it is, sometimes it isn't. Next values, we're going to add them all up. Remember, taking individual steps using the underline, evaluate, and rewrite strategy we've learned from order of operations will help you organize your work. Trying to type everything in your calculator at once provides you with a lot of opportunity to make errors. Those decimals and zeros should not change how we deal with this. So even though that 0 is not going to affect the sum, I could have 9 plus 0 plus 6 or just 9 plus 6 and get the same exact sum. It doesn't affect the overall sum, however, it counts as a value. There are still 8 values up there, 9, 0, 6, 10, 7.5, 8.2, 4, and 9. A very common mistake is to leave out that 0 as one of the terms and to divide by 7 instead of 8 in this case. In order to find the mode is the value that appears the most in a set of numeric values. A great way to remember the mode is pi a la mode, which is pi with ice cream. You don't want a little ice cream, you want the most ice cream. You want more than anyone else. So, in order to find the mode, we need to find the value that's there the most. To start, we're going to write the values in numerical order. This is an ongoing theme you'll see throughout our averages unit. So I'm going to take these values starting with 1. As I go, I cross out the values so I don't use the values more than once or forget which values I have or haven't used. 10's the next biggest, then 13 again. If there's more than one number, list them both, cross them both off, and there's 23. I started with 6 values, I ended with 6 values. It's always a good way to check that you wrote them in numerical order. Writing the values in numerical order is a great habit. It helps us when we find our mode, it helps us when we eventually find our median, and when we find our range, and when we do our box and whisker plots. This is a very helpful step for all of our different versions of the average we're studying. So now that I have them in order, I'm going to group any repeating values. What's helpful about putting these numbers in numerical order from smallest to largest is now I can see values that are repeating. They're right next to each other. 13 and 13 are next to each other. Every other value up there is by itself. There's only 1, 1, 1, 8, 1, 10, 1, 23. So there's only one group that's contending for the mode. In this case, it's 13. There are more 13s than anything else. 13 is represented the most. Let's try a couple example problems. So we start by writing the values in numeric order. Remember, if there's negatives involved, they're further down to the left on that number line. So I'm going to start with -1. If it repeats, write it twice. -1, cross it out as I go. 0.9, it's just on the other side of 0 on that number line. I keep going. 3.2, there's two 3.2s. 5 is the next biggest value, and then 9 is the next biggest value after that. Here I'm going to look for any values that repeat. I see two -1s. I see two 3.2s. Everything else is just there once. Now I look at how many of each of these repeating values I have. I have two -1s and two 3.2s. Neither one is more than the other. So in this case, -1 and 3.2 represent the most, or represent the mode. We do the same thing again. Remember, negatives are always further to the left on the negative line, so you start with your negatives. With negatives, less is more. That's a good rule of thumb. So if you're thinking 17 is bigger than 6, -17 is actually less than -6. It's opposite on the negative side. I'm going to keep going, list them all in numeric order. Decimals should not change. Just remember, 4.5 is halfway between 4 and 5, so it needs to find its way in between the two. Get them all in numeric order. That way we can look if there are any values right next to each other that are the same. In this case, there aren't any. Every value is next to a different value. So this is a case where there's no mode. So we could have situations where there's one mode, situations where there's no mode, or situations where there's more than one mode. So let's look at a couple different examples of where we'd see that, or how we call these different occurrences of the mode. So think to yourself, based on what we just looked at, is there always a mode? When it asks for a mode, is it always a value answer? Is there always only one mode based on what we just looked at? Can you find a situation where there's more than one mode? So when there's no mode, this is when there are no values that are repeating. So we just saw an example where when I put the numbers in numeric order from smallest to greatest, none of them were next to the same value, so nothing repeated. If you don't have any more of anything else, you can't have a mode. So you can have more than one mode if there are equal size sets of repeating values. We saw this on our last set of examples with -1 and 3.2. There were equal amounts of -1 and 3.2, but there were more -1 and 3.2s than any other type of value. When there are two modes, it's called bimodal. When there are more than two modes, we call it multimodal. There are a couple examples below of what a set of values with no mode and a set of values with more than one mode might look like.